And now let's proceed to practical demonstration of our capacity design. I prepared for you this kind of pre-qualified joint. It's a beam connection to column, and I have it open here. So let's proceed right into the application. Let's say I'm an engineer and I prepared this joint to pass the code check for stress strain analysis, which is the first step, and I'm satisfied. So then I will create a copy to keep that data, and now I will turn to this capacity design analysis right here at the top. Now I have some new features here. First step will be to insert the loads according to my calculations, and I calculated the loads in this way. So my bending moment for seismic analysis is this one. So let's apply it on the beam, and according to my bending moment, the shear force must be inserted. And of course, I want two load effects with opposite acting forces, so I just changed the direction. Right now, in another step, we will choose the dissipative item at the top, and we will choose it for the beam IPA 360, because I think the plastic hinge will occur here at the beam, just slightly ahead of this stiffener. And one of the last things, the stiffener is approximately 360 millimeters in the distance from the beam, from the center of the joint, from the node. So I need to fill this value here as a position. And last thing, I will change the model type for the beam because I want to have deformation only in a vertical plane of the beam itself. So great, that's it. We can turn on the calculation and let run the iteration process. As you can see, the analysis is trying to find the equilibrium, and we can see that it's not so quick because it's a little bit overloaded, and you can see that the percentage is dropping down. The application is trying to find the equilibrium in smaller increases of the applied loads. And right now we can see that our joint didn't pass the code check for the capacity design. Okay, what else? We have to do some changes in the design. Okay, I will increase the thickness of the end plate, and I will add a stiffening plate, the doubler, on the web of the column. Just give me a second. I will turn these operations on. With these welds, I will weld this doubler to flanges on both sides, and I will cut these stiffeners with the doubler. And now my modification is done, and I'm sure right now it will pass the code check for the capacity design. And you can see the calculation is a little bit more quicker now because the equilibrium is there. And right now we have our results here. So the connection passed the code check, our plates and bolts are okay, and we can, for example, check out where is the plastic hinge on the beam. And you can see that it occurs right behind the stiffener as we expected, and we are satisfied with this behavior.